In your tutorial, take question number 74. Question number 74. Question number 74 as the first question today. Right. Question number 74 says, a thin smooth tube in the shape of a semicircular arc of radius simple a and center O is fixed with its diameter joining ends A and B vertical, and the center O at a height 2a from a horizontal floor as shown in the figure. A smooth particle P of mass simple m is projected horizontally into the tube at the lower end A with velocity root 9 GA by 2. Root 9 GA by 2. Right. Show that when OP makes an angle theta with the downward vertical, the speed of the particle P is this answer, and the magnitude of the reaction on the particle P from the tube B is the given answer. Okay. Deduce that the particle P reaches the point B and the reaction changes its direction during this motion. When the particle P reaches the point B, it strikes another smooth particle Q of mass simple m, which is at rest in the tube at B. Show that the speeds of the particles P and Q just after the collision are this and this respectively, where E is the coefficient of restitution between the particles. Show also that if the particle P and Q fall on the ground at points with a distance simple a apart, then ask him to show E value is 1 upon root 3. Yeah, first we'll draw the diagram here. Right, semicircular tube like this, right? Semicircular tube. The diagram, clear diagram is important. Midpoint is O. Right? And this point is A. This is B. This is A. This is A. This is also A. Now particle P is projected from here. People, particle is P projected with the speed root 9 GA by 2. Now the particle P now moves inside the tube like this. Once it makes the OP makes an angle theta with the downward vertical, right? Somewhere here, suppose that particle P. Then if I mark the forces, normal reaction coming to this, that acts towards the center O. Where This angle given to be theta. Okay. Weight is mg. This direction we have a velocity. Let us take that as velocity v. Okay. This is the diagram. This is the diagram. And now, here now we have to find people this velocity and normal reaction. Then you know the finding of those things. How to find people then? We have to apply conservation of mechanical energy and H equals ma. Right, to apply the conservation of mechanical energy, we should have a potential energy zero level. So you know any level we can consider as the potential energy zero level. So then I am going to take the level of this A as the potential energy zero level. Any level people you can consider as your potential energy zero level like this, huh? Right, this is the potential energy zero level. Now you can write applying conservation of mechanical energy, right? This is the initial stage. This is at the time t equals t, right? Time t equals t. Here t equals 0. Okay, then here the total kinetic energy plus potential energy is here equal to here the total kinetic and potential energy, right? So now here we can write the kinetic energy half mv squared plus potential energy mean people mgh, no, this height we need. What height? This height. That height you can very easily find here, this height, no? Right, you know from here to here the whole height is people a, and since this is theta and this also radius, no, this is a cos theta. A, this is theta, then a cos theta is this. From here to here, whole height is a. From this whole height a, when you subtract this a cos theta, we get this part. So therefore mgh, it is mgh. H means this height now, people. Right? From this whole height a, subtract this a cos theta. Then we get this a minus a cos theta. Kinetic energy, potential energy sum is the total mechanical energy at this point. Here, total mechanical energy, this position is potential energy zero level, people. Then this particle has no potential energy. It has only the kinetic energy. So that is half mv squared, no? Right. Half m. V means there root 9ga by 2. Once you square that, root sign will eliminate. 9ga by 2, potential energy, people, 0. So now, we'll simplify this. We can cancel down this m. And we need to find this v squared, no, multiply by 2. Then v squared, meantime, bring this right hand side. When you multiply this by 2, people, 1, 2, we can cancel down. Then 9ga divided by 2. And once you multiply this by 2 and take to right hand side, it will be minus, right, 2g, because we multiply by 2, no, 2g within bracket a minus a cos theta. A minus a cos theta we get. Now simplify this, you get this answer, right? Answer is okay. V squared. People, I take ga divided by 2 out. Now we open a bracket. Once you take ga divided by 2 out, here we have 9. Now I take this a out. Then here we get ga. Since we have taken ga divided by 2 out, after taking this a out, we divide this by 2 and multiply by 2. Then ga by 2 we have taken out. Another 4 here we have, right? Minus 4. Now, since we have taken this a out, within bracket now we have 1 minus cos theta. Understood? Then people remove the bracket by multiplying this 4. Minus 0.1 is minus 4. 9 minus 4 is 5. Right? 5 minus minus plus 4 cos theta. This is v squared. Then taking the square root of this, we get v GA by 2 5 plus 4 cos theta. This is how we take that answer, right? We were secondly asking the normal reaction. You know, to find the normal reaction, we have to apply F equals ma towards the center. F equals ma towards the center, right? We have to apply F equals ma towards the center, right? Now you can write applying F equals ma this direction towards center. Right. So then when you produce this line, this angle also theta, r the force acting towards the center. By this mg people we have mg cos theta this direction. So then r minus mg cos theta is equal to centripetal acceleration going to be mv squared by a. Then we can subject r by this, takes the right hand side, mg cos theta plus m upon a v squared. V squared means people this answer, right? It is g by ga by 2 5 plus 4 cos theta. Five plus 4 cos theta, right? So now we can simplify here. This and this we can cancel down. Mg by 2 we have there. Right, I take mg by 2 out. So, but here we don't have 2, no. We divide this by 2, multiply by 2. Then taking this mg by 2 out. Here now we have 2 cos theta. And here mg by 2, this part. When I take this mg by 2 out, people, here we have 5 plus 4 cos theta. Then r comes as mg by 2 5 plus 6 cos theta. This way we can take r. Normal reaction. Right? For that one, answer people. Right. Right, no? Right. Up to here, I think you can very easily take. Okay. Right. Then I write these two results to get the space here. V equals GE by 2 5 plus 4 cos theta root, and R is mg by 2 5 plus 6 cos theta. This way we have the two answers, right? Now, I will this. Right, now next thing is asking this way. Deduce that the particle P reaches the point B and reaction changes its direction during this motion. Deduce that the particle P reaches the point B. Particle P now moving this way, people, asking to show the particle P reaches the point B, right? Now, in this case, the particle P is moving inside the tube. So therefore, people, the particle has to move in a circular motion. Then while this particle is moving inside this tube, the particle should make a contact with this outer surface. That means inside the this surface I am saying now, inside the tube, we have outer surface and inner surface, right? So the particle, while it is moving inside the tube, you can very clearly understand this particle makes contact with this outer surface or inner surface, right? As long as the particle makes contact with this outer surface, the normal reaction acting towards the center, okay? And once it makes the inner surface, the normal reaction coming to the particle by the tube is outward, away from the center, okay? So now people, once the particle moves like this, it can't go away from the circular motion. The possibilities here, if the velocity of the particle becomes zero somewhere here, particle comes to instant rest there and backward it moves on the same path, backward direction, okay? So therefore, in this case, when you take the condition required for this particle P to reach at the point B is, people, particle should have enough velocity to reach this point B. So therefore, in order to reach to the point B, the condition required for the particle P is, people, once the particle reaches the point B, right, it should have a positive velocity or zero velocity. If the particle has the velocity positive or zero at the point B, people, definitely particle can reach the point B. That means the velocity of the particle should not become zero until it reaches to the point B. Until it reaches to the point B, the velocity of the particle should not be equal to zero. So therefore, in order to show that the particle can reach to the point B, what we do is this, people. When the particle P comes to the point B, this angle theta will be 180. We substitute here 180. Right? So thereafter, we simplify this. You know, this V is square root of something. Right? Now, suppose here, when you put here theta pi, if this answer is positive, people, square root of that positive answer can be found, then the velocity exists. Velocity exists. Where? When theta equals pi. When theta equals pi means particle is at the highest point B. At the highest point B, particle has the velocity. That says, people, particle can reach the point B. Now, for example, suppose when you put theta equals pi here, this expression inside the root sign becomes negative. Then to determine this V, we have to take the square root of negative value. Square root of negative value we can't find. It says the velocity V does not exist. Where? When the particle P reaches to the point B, its velocity, not a real value, that kind of velocity does not exist. That means, people, particle does not come to the point B. Before point B, the velocity of the particle 0. Then what happens? No longer particle moves, it comes back. So therefore, in order to show that the particle P reaches the point B, we have to put theta 180 and corresponding velocity existing value we have to prove, right? Okay. Now we can say when theta equals pi, what is V? V is square root of GA by 2 pi plus 4 cos pi. Theta is pi, no? Then cos pi is equal minus 1, right? Cos pi is minus 1. Then we get V equals square root of GA by 2 pi. Here minus and plus make minus 4. Then we get V equals root GA by 2. You can very clearly understand, people. Very clearly understand. This is a positive figure. Then we can find a root for that. Then this V exists. That means when theta equals pi, that means at the highest point B, the particle has a real value for its velocity. That says particle reaches to the point B. Understood? All right. This is a real value. Therefore, V exits at theta equals pi. Hence, particle reaches to the point B. Particle reaches to the point B. That is how we prove that part. Right. Now, next part. Deduce that the particle P reaches the point B and the reaction changes its direction during this motion. Reaction changes its direction. People, in this case, reaction changes its direction means, now you know people here, once the particle moves from here to here, when it is here, reaction is this direction. When the particle comes here, reaction is this direction. Then you can see from here to here the motion of the particle. The reaction actually changes the direction. Right? When the particle is here, direction is this. When the particle here, direction of the reaction is this. There you might understand that change. No. The direction of the reaction changes means not that change. People, in this case, direction of reaction changes mean, now in this somewhere here, people, now when we consider this one, the reaction is towards the center. Towards the center, inward. Now, one occasion, people, once the velocity of the particle decreases, right? One occasion, the particle make contact with this inner surface. Here, somewhere here, the particle might contact this surface. That occasion, the reaction coming to this particle is, people, away from the center like this. So, see here now, somewhere here, the direction, the reaction acts towards the center. Somewhere here, away from the center. Away from the center. That change only people are seeing here. Then change in the direction of the reaction means from inward direction to outward direction. From inward to outward, the direction changes. That change only people here mean by the direction of our changes, reaction changes. Understood? Right. So now here we can see. Okay, I can show it like this. I take this R figure. This R I take. R equals mg by 2 pi plus 6 cos theta. Right. You can see when theta is an acute angle, that means until the particle reaches this level, Theta is acute, no? When theta is acute, this cos theta is positive. Then this within bracket is positive. Here that should be multiplied by mg by 2. This is also positive. Then r is positive. That means until this level, r is positive means the direction of this r is pointing towards the center. Okay. Then r positive in the initial stage until this. Sometimes above this level also positive. Anyhow, people, right? There is a particular motion for the particle. During that motion, the reaction R acts towards the center because R becomes positive. Okay, right. Now we can say this is R positive, people, right? R positive, but now this is greater than 0. This is greater than 0 initial stage because that's very obvious. Theta is acute. Okay. Now let's put theta equals pi. We are here. Then you can say R equals mg by 2 5 plus 6 cos pi. Right. Actually, now I am going to put here theta equals pi. Theta equals pi means I am going to find the reaction when the particle comes to the point B. That is the meaning of theta put in pi. Theta is pi. Then you know cos pi is -1, people. Then R is equal to mg by 2 5 plus 6 and -1 is -1, -6. Then this is -1, no? Now mg by 2 here -1, minus mg by 2 coming. Right. Now people, we said during a particular portion of the motion, the R acts towards the center. But anyhow, people, once the particle reaches to the point B, R negative. R negative means somewhere here when the particle moves, it moves. The reaction acts towards the center. Once the particle reaches the point B, reaction going away from the center. That means reaction acts away from the center. Right? So now direction has changed, no, people? Right? The reaction initially in the early stage of the motion acts towards the center. Once the particle has reached the point B, the reaction acting outward from the center. Then the direction from inward to outward, that has changed once the particle reaches to the point B. So now people, you can very easily say then during this motion, the direction of the reaction changes. So therefore, in between this level and this level, somewhere between these two levels, the reaction changes its direction. If we need to find people the exact position, on the exact place where this reaction changes, you know, reaction changes when its value becomes 0, because this stage, this motion up to here, velocity positive, not velocity positive, R positive. Once it comes here, R negative, then positive to negative. When something changes, that should happen going through 0. Understood? When the reaction here positive, here negative, that reaction decreases from positive to negative. Then one occasion that should pass to the value 0. Thereafter only it can come to the negative. So therefore, that instant R becomes 0 is the point. Understood? Is the point the reaction changes. Understand? So in between this level and this level, the motion in between that two levels, the reaction people changes, right? Okay. So then we can write, therefore, the direction of the reaction changes. The direction of the reaction changes. Right. Right. Now next part. Now the particle P reaches the point B we found with velocity root GA by 2. With velocity root GA by 2. Okay. Now we are given, once the particle P reaches to the point B, there is a stationary particle Q of mass simple length at the point B. Okay, right. That means here particle P comes like this. P that comes to the point B with velocity root GA by 2. Now there are another stationary particle available. It is Q of same mass. Then there will be a collision, people, between these two. After the collision, we'll take the velocity with which they begin to move. Let us, the velocity of P is V1, that of Q is V2. Then ask him to find this V1 and V2. Right, people? V1 and V2. How to find this V1 and V2? V1 and V2 can be found, people, by applying conservation of linear momentum and the Newton's law of restitution we learned. Understood? Huh? Right. We'll come to that now. Okay. Right. Now here we have Q, right? Okay. Now for the collision, we can applying conservation of linear momentum rightward. What is that, people? The total momentum before impact is equal to total momentum after impact. After impact, total momentum to the rightward direction going to be mv1 plus mv2, right, is equal to momentum before impact, m root GA by 2, number 1. Right, we can cancel down first this m, people. v1 plus v2 is equal to root GA by 2. This is number 1. Secondly, we can apply Newton's law of restitution rightward. Newton's law of restitution says us, people, what? Minus E times relative velocity before impact equals relative velocity after impact. Before impact, only this P is moving, Q is at rest. Then after the impact also, by stopping this Q, we'll find the velocity of P to find out the relative velocity. Before and after, then we have found the relative velocity of P relative to Q. Velocity of P relative to Q. Right. Apply Newton's law of restitution. It is minus E times velocity, relative velocity before impact. Before impact, only P is moving, Q is at rest, right? It is therefore the relative velocity root GA by 2. After the impact, again we have to stop what this Q, no? Once we stop this Q, we have to apply V2 leftward and P also V2 leftward. Then Q will be at rest. P will have rightward velocity V1, leftward V2. Then rightward direction only V NLR applied. Then it is V1 minus V2. This is number 2. Now by solving this 1 and 2, people, we can find V1 and V2. At 1 and 2, then these 2 will cancel off. We get 2V1 is equal to this thing you can take out, square root of GA by 2. Here 1 minus E come in. Then V1 we get what, people? 1 minus E divided by 2 times root GA by 2. Similarly, taking 1 minus 2, we get V2 1 plus E by 2 square root of GA by 2. This way, we can find the velocities of the particles P and Q soon after the collision. Okay. Right now, you can very clearly see out of this V1 and V2, this V2 is greater, because the reason root GA by 2 here and here we have, this 2 also we have, and here we have 1 minus C, but here we have 1 plus C. This 1 plus E factor greater than this 1 minus E factor. So therefore, this V2 greater than V1. V2 greater than V1 means after the collision, the particle Q moves faster than the particle P, right, horizontally, right? So then we can then mark like this. This is the V2 now. Particle Q therefore has greater velocity, that therefore moves more distance than P moves. More horizontal distance that moves. Both the particles P and Q initially, soon after the impact, people, vertical velocity is 0. Right. So then particle Q moves this way, particle P moves now this way. It has lesser velocity. V1 is less than V2. Now they will fall to the ground at 2 points, right? The gap between these 2 points given as people simply. Then asking to find people the E, coefficient of restitution. Now the motion is a projectile motion. See here in this question, how many lessons join together? Circular motion, impact of elastic bodies, and projectile motion. 3 motions involving, right? Yeah. Then people, first of all, we will find the time taken by the 2 particles P and Q to reach the ground. You can very clearly understand both are moving under gravity. Initially, both this P and Q didn't have people vertical velocities. Right? Before reaching to the ground, both P and Q must descend a height A3A height, they must descend with initial velocity, people, vertical initial velocity 0 for both P and Q. Right, people? Now, that is to say, when we consider the vertical motion of both P and Q, both P and Q start their vertical motion downward direction with initial velocity 0 downward direction. So therefore, once the both particle reaches the ground, they reach the ground simultaneously. Why? P and Q both take the same time to reach the ground. Why? When they start their projectile motion under gravity, both P and Q had vertically downward initial velocity 0. Right? So therefore, if we apply equation of motion considering the motion of one particle, right, P or Q on downward direction, we can find the time they take to reach the ground. Understood? Right. And then we can write here. We can now write for the motion of Q applying S equals ut plus half at squared vertical downward, you must descend a height a 3a. Initial velocity is 0, people. 0 times t plus half gt squared. Then this is 0. 6a divided by g is equal to t squared. T is therefore the square root of 6a upon g. Now this is time. Now what I do is, we'll find now the horizontal displacements traveled by this both p and q. That can easily be found applying s equals ut for both p and q rightward, right? Now you can write now applying s equals ut rightward, number 1 for p. What do you get? I apply s equals ut for this p rightward, then I take the horizontal distance traveled by p as sp, right? Why don't you have here half at squared? Because the horizontal motion of the particle, they don't have acceleration. Then that a of the equation of motion s equals ut plus half at squared, a is 0 now, then half at squared whole thing is 0. Then sp is going to be, particle p has the velocity v1 soon after the collision times t. And number 2 for q, we apply rightward, that is sq, v2 times t. We will now, this sp means this length. Sq means this length. Then this length mean, people, sq minus sp. Sq minus sp. Sq minus sp only simple a. But you can write, but sq minus sp is equal to simple a. Okay. Now you can write sq is v2t, sp is v1t, it is equal to a. Right. Now we can take this t out, people. v2 minus v1 times t equals a. v2 minus v1 we can calculate by the number 2 equation. When you interchange the order, we get to the left hand side v2 minus v1, right? Then we get minus sign, or else when we multiply both of these sides by minus sign, left hand side v2 minus v1, right hand side this will be plus, no? E times square root of g by 2 times t. T is this, square root of 6a by g is equal to a. Now here we can simplify this. This root g you can cancel on with this root g. This root a and this root a, when you multiply, we get simple a to the left hand side. That a you can cancel down with right hand side a. Now here we have e times root 6. Here we have divided by root 2, right? E times root 6 divided by root 2 equals 1. This root 6 divided by root 2 we can write in a single root as square root of 6 by 2. Understand? E times square root of 6 by 2. This way I can write. This and this we can cancel down. Thereby we get E as 1 upon square root of 3. That's the final answer. That's the final answer. Right. This way we can take this answer, right? Right. Now we'll come to the next question as question number 75. Take question number 75. Take question number 75 in the tutorial as our next question. Right, first read the question and draw the diagram and try to get the first answers. Right, question number 75 says a thin smooth tube ACB in the shape of a circular arc of radius simple A that subtends an angle 5 pi by 6. 5 pi by 6 means people 150 degrees at its center O is fixed in a vertical plane with OA horizontal and the lowest point C of the tube touching a fixed horizontal floor as shown in the figure. A smooth particle P of mass simple m is projected vertically downwards into the tube at the end A with speed root 2GA. Show that the speed of the particle P when OP makes an angle theta with OA is this much. And the magnitude of the reaction on the particle P from the tube is this answer. The particle P, when it reaches the point C, strikes another smooth particle Q of mass simple m, which is at rest inside the tube at C. The coefficient of restitution between the particles P and Q is half. Find the speed of the particle P just before the collision and show that the speeds of the particles P and Q just after collision are this and this respectively. Show further that the particle P never leaves the tube and that the particle Q reaches the point B with speed half root 5GA. Find the maximum height from the floor reached by the particle Q after it leaves the tube. Right. This is also a very good question. Right. First, we'll draw the diagram. Angle 5 pi by 6. It is 150 degrees. Lowest point C. Lowest point is C. Point C, here there is a particle. Stationary particle is here. Which has mass simple m at C, right? This is Q. Particle Q is this. Here A, this is B. Right, now a particle is projected from here. P with vertical velocity, downward direction, it's a root 2GA. Root 2GA. P also has the mass simple M. Okay. Now, what is first question asking? When OP makes an angle theta with OA, that OP makes an angle theta with OA, all right. This is the point, this is a particle P. Here O. This P normal reaction acts. R. This angle is theta. This is a particle P. Weight is mg like this. Right. So then the velocity here I take, that's actual on the tangent, no? V. This of the particle P is V. That velocity acts along the tangent. V. In this angle, this is theta with the vertical therefore 90 minus theta, no? So therefore this is 90 minus theta this time. 90 minus theta. Right, asking the speed. Apply conservation of mechanical energy. Apply conservation of mechanical energy. Applying conservation of mechanical energy. Right, there we need people potential energy 0 level. So I'll take this level as potential energy 0 level. Here then the height from this is simple A, no? The radius given as simple A, no? Radius is simple A. Then we can write the initially total energy half m 2GA plus mGA, total mechanical energy. Right? And at this level, the total mechanical energy we can write when you make a construction like this. This height we need, right? Here the kinetic energy half mv squared, half mv squared. Potential energy, we need this height. Whole height is A. This height is A sin theta. Then this height going to be A minus A sin theta. mg A minus A sin theta. This way. right now. Then you can cancel down this m, right? This 2 also we can cancel down. Now multiply by 2. Then here we get v square. Bring this right hand side. Meantime, take a out 10. Since we multiply by 2, we get, right. What do you get here? When you multiply by 2, here GA and GA make 2GA. When you multiply that by 2, we get 4GA. When I take this right hand side, that will be minus. Meantime, take A out. Since we multiply by 2, we get minus 2GA 1 minus sine theta. This is what we get. Then we can take here, people. 2GA you can take out. Then here we have 2. Here remove the bracket by minus sign, minus 1 plus sine theta. Then we get V as square root of 2GA 1 plus sine theta. This is the first answer. This is the first answer. Next one asking, and the magnitude of the reaction on the particle P from the tube B is this R has to be found now. Now we apply F equals ma. This direction OP. Okay, right. Applying F equals ma. Right, we can take that one. Right, so then there this direction R mg cos 90 minus theta right now. This direction is R mg cos minus 90 minus theta equals mv squared upon a. Then we can subject R by this. R is equal to, bring this right hand side, mg sine theta plus m upon a. For this v square, I substitute this 2ga 1 plus sine theta. A and a you can cancel down. R, you can take this mg out. Once you take this mg out, here we have sine theta. When you take here mg out, we have another 2. Then we get 2 plus 2 sine theta. Then we can write this one. R equals mg 2 plus 2 sine theta and 2 sine theta means 3 sine theta, right? This is how we take that. Right now, people, the particle P moves inside the tube like this and reaches to the lowest level C. Then ask him to find the velocity of P just before reaching to the point C. Just before means exactly at the point P, just before the impact. Yeah, these two answers I think you could get very easily. Class of V is square root of 2GA plus 1 plus sine theta. Right. Then at C, if you need to find the velocity of P, once the particle P reaches the point C, this theta will be 90. Theta will be 90. At C, theta is 90. 5 by 2. Put that we are here. Therefore, V GA plus sine pi by 2. Sine pi by 2 is 1. 1 plus 1, 2. 2 and 2 make 4. Root 4 is 2. 2 root GA answer. Is the velocity of the particle P reaching at the point C. Reaching to the point C. Now, with this velocity only, the collision takes place. Right. Now, collision between P and Q, we can write. Collision between P and Q. Right. This is just before the particle P. It moves with velocity 2 root GA. Now, the P and Q collide. Then suppose they begin to move with velocity V1 and V2. This is P, this is Q. Now we can apply conservation of linear momentum rightward. Right. After the impact, total momentum is equal to before impact total momentum. Only P was moving m times root 2 root GA. M you can cancel down. V1 plus V2 is equal to 2 root GA. This is number 1. Now we can apply Newton's law of restitution. Newton's law of restitution, this direction. We are given the coefficient of restitution as people half. Half. Then what is the Newton's law of restitution? Minus E times relative velocity before impact. Before impact only P was moving, Q was at rest, no? Right. So then minus half this 2 root GA. After impact again, we have to stop this Q. Apply V2 leftward on this P2. When I apply V2 leftward, this will be at rest. V2 leftward, this P will get rightward V1 minus V2. This 2 and this 2 you can cancel down. The second equation there we get V1 minus V2 is equal to minus root GA. This is people number 2. Number 2. Right, now we need to find this V1 and V2. Yeah, there you have to add these 2 equations. 1 and 2 when we add. What do you get? Here, V1 and this V1 make 2 V1. Add in the right hand side. 2 root GA, there we get people. Then GA, no? GA root. Then V1 going to be half root GA. Taking 1 minus 2, we get what? V1 and V1 you can cancel down. V2 minus V2 is 2V2 equals this minus, that means 3 root GA coming. Then this gives us V2 equals 3 by 2 root GA. That way we can take the answer. Right. Now asking to show this one, what people show that the particle P never leaves the tube. Particle P never leaves the tube. Right. Now particle P has the velocity V1 after the impact, no? Right. So then if I draw, this is the point C. Right. This is the point O. Here particle P has the velocity V1 after the impact. Now B is here. Now we have to show particle P does not reach to the point B. Right. Now I am going to assume particle P comes to the point B with velocity W here. I am going to assume particle P comes to the point B with velocity W. But we have to prove particle P does not come to the point B. Right, I assume that particle P comes to the point B with velocity W. Now by using conservation of mechanical energy, I find this W. Once you find this W will be imaginary value. W is not the real answer, right? That says W squared will be a negative answer. Then W can't be found. No? That says W does not exist. That means such velocity W does not exist, right? If the particle P comes to the point B, it says particle P does not come to the point B. Understood? Huh? Right. And then for P you can apply. So potential energy 0 level is people, still this I can take, or else any other level also you can consider here. Right. So you know this angle, whole angle was people 150, no? 5 pi by 6 is 150. When you subtract 90, this is 60. Okay. Then applying conservation of mechanical energy for this P. Conservation of mechanical energy for P, we get half mv1 squared. Here it's potential energy is 0 and equal half mw squared, and this height we need. This is A, this is A. Then you know this height is A cos 60, this height. That means A by 2. Therefore, this is also A by 2. mgh, mg A by 2. Cancel down like this. And 2 also we can cancel down. Then we can subject W squared. Bring this to this side. V1 squared minus GA. But V1 is people this answer, then V1 squared going to be GA divided by 4 minus GA. W squared will be minus 3GA by 4. See here, W squared we get minus 3GA by 4. Understood? Then how to find W? We have to take the square root of this, no? W is equal to the square root of minus something. You know, we can't find the square root of negative value. That doesn't exist. Such value we can't find in real numbers. Understood? So therefore, we say this W does not exist. Such W velocity does not exist. That means this W does not exist. In the sense, when P reaches the point B, P does not have a real answer for its velocity. That means this situation, that means the rising or coming this particle P to this level of B does not exist. That means particle P never come to the point B. It says particle P never leaves the tube. Why? In order to leave the tube, people, particle P should come to the point B. Thereafter, it should come to the air as a projectile motion. But particle P doesn't reach the point B, no. Somewhere here, before coming to point B, somewhere here, velocity of the particle P becomes 0. Then what happens? That goes back. Then it will be what? Oscillating inside the tube. Right. Hence, W does not exist. W does not exist. Hence, particle P does not reach the point B. Therefore, particle P never leaves the surface. Never leaves the tube, not surface, tube. Never leaves the tube. Okay, right. Now asking to show particle Q reaches the point B with speed this R, right? Now we'll count that Q. Right. Again, we can apply velocity of Q, we can consider on reaching the point B as W dash. Then again, we can apply conservation of mechanical energy, right? Okay. Okay, you see. Q here, moves with velocity V2, come in here with velocity W2, W dash, see, or W or W dash, see. Now applying conservation of mechanical energy, again you can find this W dash. This is potential energy zero level. We can find W dash. I shall erase this now. By conservation of mechanical energy of m V2 squared is equal to half m W dash squared plus mg by 2, as before, mg by 2. This 2 and m, 2 and m, 2 and m you can cancel down. V2 is this much, then put that here, 9 by 4 Ga, brings this side Ga equals W dash squared. Then here we get 5Ga by 4 as the W dash squared. That gives as W dash root of 5Ga by 2. Correct, no? Right. Now people are asking, find the maximum height from the floor. Find the maximum height from the floor reached by the particle Q after it leaves the tube R. People, after leaving the tube, the particle B, that begins the projectile motion like this. It moves now as a projectile motion. Now asking to find what is the maximum height attained by the particle Q from the ground. Then this is the level of projection. This is A by 2. Okay. This is 60. So now in this case, the W dash velocity is along the tangent. Along the tangent, right? So therefore, right, we can apply right? The equation of motion to find this highest point, the height is the maximum height. It reaches above the level of B. To that h, we have to add this a by 2. Now here it's 5 by 3 angle. When I draw a vertical line here, people, this also 5 by 3, that means 60. Therefore, this is 30. This is 30. Then from here, the particle Q moves under gravity as a projectile motion. Then considering this motion from here to here, we can apply v squared plus v squared equals u squared plus 2as vertically upwards. Thereby you can find out that height h. Because at the highest point, you know the velocity is 0. Okay, then you can write applying v squared equals u squared plus 2as for q upward direction. People, what is the initial velocity? Upward direction. Now you know w dash. That w dash direction is perpendicular to this radius. Then w dash cos 30 is the vertical velocity component. At the highest point, the vertical velocity component of the particle q is 0. Therefore, v squared is 0. U means w dash squared. That means w dash cos 30 perfect squared. No, w dash cos 30 perfect squared minus 2g h. I take that as h. Take this side. W dash squared cos 30 means root 3 by 2 perfect squared. 2gh is equal to w dash squared going to be, people, the root will eliminate, 5ga by 4, here 3 by 4. 3 by 4. Then we can simplify this. T and this T you can cancel down. Then we get h equals 15a divided by this 2 wants to bring here, this and this 16 into 32. H is this. That is this height. But we asked to find, asking the height from the ground. Then to this h, we have to add this also, a by 2. Therefore, height above the ground. Therefore, height above above the floor. What's that? A by 2 plus 15a by 32. Then 32 is the common denominator. This is 16a, 15a, 31a. This is the height above the ground it reaches. This is how we take that answer. Right. Now, as the next question, we'll take question number 76. We'll take the question number 76 as the next. Take question number 76 as the next question. Read question number 76. Right, that question number 76 says a narrow, smooth circular tube of radius A and center O is fixed in a vertical plane. One end of a light inextensible string of length greater than 3 pi times a by 2 is attached to a particle P of mass m, which is held inside the tube with OP horizontal. The stream passes through the tube and through a small smooth hole at the lowest point of the tube as shown in the figure, and carries a particle Q of mass 2m at the other end. The particle P is released from rest from the above position with the spring taut. By applying the principle of conservation of energy, show that the speed v of the particle P, when OP has turned through an angle, this theta, given by this answer. Find the reaction on the particle P from the tube. Right. Particle P has turned through an angle theta. Right. Particle P, right? Here, small hole we have. Use this way. The spring is this way. Q of mass 2m. This is 2m. Q mass 2m. This is P mass m. Right. Now, system is released from this position. Then what happens? Particle P, suppose, comes to a position somewhere here. Right? Getting a velocity v. Right? Once you join that point, particle P, to the center, this angle now theta. Right? Now, this way, when the particle P moves from here to here, it has moved an arc length here. It has moved an arc length. This arc length, right? Radius is a, the angle is theta, therefore this arc length is a theta. A theta. Once this particle P moves this arc length from here to here, a theta, the particle Q will descend by that arc length downward, a theta. Understand? This arc length a theta, the particle P moves a distance a theta, right? Then during the same time interval, Q moves downward another depth a theta. Here. A theta is height. Q. And the other thing is, if the velocity of P is V, this end of the string has the velocity P, then the other end also of the same string should have the same velocity V. Understand? This Q also at that moment should move with velocity V. Right? Now, on this particle P, a normal reaction coming outward, right? R, right? This is the tension T acts. Tension T acts on the tangent. Right. Okay. People, initially I'll take this height to this Q from here as capital H. This radius is A. Right. Now to take the first answer, people, we have to apply conservation of mechanical energy. Understood? There, I'll take the potential energy zero level as this level. Initially, particle P here, this is at T equals 0. Here, Q at T equals 0 is here. Here, particle P at T equals T. Here it is at T equals T. Okay. Now, at T equals 0, the total mechanical energy we have tried. Energy of this P and energy of this Q. That is the system now, right? There are two particles in the system in this case. There are two particles in the system in this case. One is P, other one is Q. At T equals 0, P here, Q here. Then at T equals 0, you have tried the total energy. Both P and Q at rest. No kinetic energy, but they have potential energy. And we have tried that. Secondly, at T equals T, we must write the potential energy plus kinetic energy. At T equals T, Q is at this level with moving with velocity V, P is here. Moving with velocity V. Then you can write the total energy, right? Then you can write applying conservation of mechanical energy. Right? We can write, people, the energy theory. When you write the energy theory, we get at T equals 0, P is at the potential energy 0 level, no potential energy, and it is not moving, no velocity, therefore P has no, what, people, kinetic energy. Q is at rest, no kinetic energy, but it has potential energy. A and H is the depth from the P is 0 level. There the potential energy of Q is minus 2m, mass is 2m, G, H plus A, H plus A, H plus A, right? Minus 2mg, H plus A, right? is the energy at t equals 0. T equals t, we have to write the kinetic energy and potential energy of P and that of Q. Right. Then we can write half P has the mass m, whereas V squared plus mg, its potential energy going to be here. This is A. Therefore, this height is A sine theta. Mg A sine theta. Plus here kinetic energy half mass is 2m V squared plus its potential energy people negative, because that is lying below the PE 0 level, minus 2mg A plus H plus A theta. A plus H plus A theta. A plus H plus A theta. The total kinetic and potential energies. So now when you simplify this, the first answer you can take. Then here we can cancel down this m. M we can cancel down. 2 also we can cancel down. Then we'll write, give the bracket here, minus 2gh minus 2ga equals v squared by 2 plus ga sine theta plus v squared minus here 2ga minus 2gh minus 2g A theta. This minus 2gh, this minus 2gh you can cancel down. This minus 2ga, this minus 2ga also you can cancel down. Then when you subject v squared, left hand side now we have 0. V squared by 2, v squared means 3v squared by 2. Plus here and over there you can take ga out. We get sine theta here minus 2 theta. Then you can subject v squared, take this to this side, then we get 3v squared by 2. Once you take this to this side, we get minus ga sine theta minus 2 theta. Remove the bracket by multiply minus sign, then subject v squared. Therefore, 2/3 ga 2 theta minus sine theta is the v squared. 2ga by 3, 2 theta minus sine theta. This is how we take that answer. Now asking and find the reaction on the particle P from the tube. That R we have to find. R can easily be found, people. This tension T is perpendicular to this R, because this tension T acts along the direction of the tangent drawn to this tube at this point. So then when we apply F equals ma, this has a mass, no, therefore it has a weight. Weight is mg. Now we can apply F equals ma towards the center. This angle is 90 minus theta, mg cos 90 minus theta is mg sine theta, minus r is the centripetal force. Right. Now you can applying F equals ma this direction for P. What do you get? Mg sine theta minus r equals mv squared by a. Mg sine theta minus r equals mv squared by a. Then r can be subjected. Take this right hand side, bring to this side. R is equal to mg sine theta minus m upon a v squared. For the v squared, you can put that down. 2g a by 3 2 theta minus sine theta. A and a you can cancel down. R equals mg sine theta minus 2 mg by 3 2 theta minus sine theta. You can take this mg by 3 out. Then this will be 3 sine theta. When you take mg by 3 out, multiply by minus sine, minus 4 theta, minus plus 2 sine theta. When you take mg by 3 out, by minus 2 we have to remove the bracket, minus plus 2 sine theta. Then we get R equals mg by 3 sine theta plus 2 sine theta is 5 sine theta minus 4 theta is the normal reaction R. Right now, right. Right now, as our next question, we'll take question number 80. We'll take the question number 80 as our next question. Right? Take question number 80 as the next question. Right. Before going to this question number 80, I'll remind one small technique here. That is this. Now consider a particle moves on a circle. Particle moves on a circle. Right? Center is O. Suppose radius is R. Suppose the particle is here at t equals 0. At t equals t, particle is here. Right? Then this arc length is, suppose this. The angle the particle has turned through at the center is suppose theta. During a time interval t, the angle at the center increased by theta. Then you can write here, is the arc length is equal to r times theta. Arc length is equal to r times theta. Now, we can differentiate both sides with respect to time t. Differentiate in both sides with respect to time t. We get ds by dt is equal to, this r is the radius of the circle, it is a constant, r times d theta by dt. R times d theta by dt. Now ds by dt mean the rate of change of arc length. Right? In 1 second, the change of arc length. That is the tangential velocity. V. R times d theta by dt we denote by theta dot people. Theta dot. What is theta dot? Rate of change of angle at the center. Angular velocity. So therefore, we use the notation theta dot to denote the angular velocity. Theta dot is the angular velocity. So therefore, hereinafter, when we find a question during a time interval simple t, right? If the particle has turned through an angle theta, then the angular velocity of the particle we write as theta dot. Then here this tangential velocity at this moment along the tangent, this velocity will be written as r theta dot. R theta dot. Okay. Now again we differentiate this. Can write again differentiating v equals r theta dot with respect to time t. What do you get? dv by dt is equal to r times d theta dot dt. dv by dt means, people, here v means the velocity, no? Tangential velocity is the v. Right? Then what is dv by dt? Rate of change of tangential velocity. Rate of change of velocity means what, people? Acceleration. So therefore, this time this dv by dt means tangential acceleration. Right? Tangential acceleration, this one. Suppose A equals, this is denoted by theta double dot. What is this theta double dot? Theta dot is what? Angular velocity. Then d theta dot divided by dt means what, people? Rate of change of angular velocity. Rate of change of angular velocity means in 1 second increment of in 1 second increment of angular velocity. Right? Rate of change of velocity means what, people? Acceleration. So therefore, theta double dot mean what? Angular acceleration. Right? So therefore, here A is what? Tangential acceleration. Theta double dot, angular acceleration. Right? So therefore, hereinafter, people, if we are given the particle has turned through an angle theta during a time interval t, then its angular velocity we mark as theta dot, angular acceleration we mark as theta double dot. If the angular velocity is theta dot, then the tangential velocity is going to be, since v equals r omega, r theta dot. That is a standard notation we use that whenever we need to work out questions, right? So in this question also, people, that thing we have to use. So therefore, we will take down this as a knot first, right? Right? Write down as a knot. Write down like this. Suppose the particle capital P moves on a circle of center O and radius A, of center O and radius R, of center O and radius R, of center O and radius R, and arc length is and arc length is during a time interval t, turn in an angle theta, turn in an angle theta at the center, right? Right on people this. Kalian lamai. Mereka katakan right. Now we come to the question number 80. It says a narrow smooth tube ABCD bent into the form indicated in the figure below. The portion AB of the tube is straight. The portion BCD is of semicircular shape with radius A. Center O and the diameter BD perpendicular to AB. The tube is fixed in a vertical plane with AB horizontal and uppermost. Inside the tube, there is a particle P of mass M and a particle Q of mass 3m connected by a light inextensible string of length L. Initially, the string is taut line AB with the particle Q at the point B. The particle Q is slightly displaced from this position, and in time t, radius OQ turns through an acute angle theta. Applying the principle of conservation of energy, show that this answer, hence or otherwise, show that the acceleration of the particle P is 3g/4 sine theta. Find the reaction from the tube on the particle Q and the tension in the string at time t. Right. Okay, we'll do a diagram. Right. Particle P is of mass m, Q of mass 3m, connected by a light string. Initially, the string is taught line AB with the particle Q at the point B. All right. Initially, Q is here. Right? P is here. And now this Q is slightly displaced. Then that moves, right? A certain arc length. Here Q. Mass is 3m. Therefore, the weight is 3mg. Okay. The normal reaction come in. This is the R. This angle given as theta. The radius, this is A. Then along this direction, you know the velocity, right? At time t equals t here, the particle has turned through an angle theta because initially Q was here, no? Initial Q was here. During a time interval t, that Q has turned through an angle theta. Therefore, we know the way of writing angular velocity. It is theta dot. Then what is the tangential velocity? Radius times theta dot. A theta dot here. Then the string will have tension. Here at time t equals t, the particle P. Particle P has mass m. So therefore the weight is mg. On it, a reaction acts, suppose that is S. Tension in the string acts T. This way. Right? This is a diagram. Right? Now, ask him to apply principle of conservation of energy. Initially, both the particles P and Q lies in the straight part of the tube. If I take this level as potential energy 0 level, initially both this P and Q have no energy. They were at rest initially and they lie at the level of potential energy 0. Initial energy of the system is 0. At time t equals t, Q is here moving with velocity a theta dot. Then the same velocity will have for this P. The reason is at the two ends of the string, the velocities must be equal. You know, when a breakdown vehicle is towing by another vehicle, they are joined by a string. When the string is stretched, taut, and both vehicles will move, people, the velocities of the vehicles should be equal. When the spring is stretched and taut, while both vehicles are moving, the velocities of the vehicle should be equal. That means at the ends of the string, the velocities must be equal. Like that, when this is moving with velocity a theta dot, this end should move with the same velocity a theta dot. Now we can apply conservation of mechanical energy. Applying conservation of mechanical energy, we can obtain the first answer. We can obtain the first answer, right? Okay, we'll write then. Applying conservation of mechanical energy. Initial energy is 0. Here, kinetic energy and potential energy. Right. This is the depth now. This is a cos theta. From here to here, it's a. From this a, when you subtract a cos theta, we get this a minus a cos theta, right? The kinetic energy here, half. Q has the mass 3m. Velocity squared means a theta dot is the velocity, it's perfect squared. Half mass into velocity squared is the kinetic energy. Its potential energy minus mass g height. Height is, people, this a cos theta, this part, whole thing is a. From whole thing, when you subtract a cos theta, we get this a minus a cos theta. That potential energy become negative because particle Q lies below the potential energy 0 level. And another energy the system has, that is the kinetic energy of the particle P at time t equals t. It is on the level of potential 0. So therefore, no potential energy for this particle P at t equals t. It's kinetic energy only. Now we write it is half m a theta dot squared. Velocity is r omega, no, v equals r omega. Omega is theta dot. A is the radius. This is equal to initial velocity. Initial velocity means, people, initial energy, not velocity. Initially velocity is 0. Therefore, no kinetic energy. Initially they are at the AB level, no potential energy, 0. Right. So now we can simplify this. By simplifying this, we can take the answer of d theta over dt, perfect squared. D theta over dt mean what, people? D theta over dt means theta dot. Asking theta dot squared answer. Theta dot squared answer. Then we can first cancel down this m. Right. And we can multiply by 2. Then here we get 3. Meantime, square this a squared, theta dot squared, and multiply this by 2, we get 6g. Take this a out, 1 minus cos theta. When you multiply this by 2, we get a squared, theta dot squared is equal to 0. Here we get 1a, you can cancel down. 3a theta dot squared and a theta dot squared means 4a theta dot squared. Bring this right hand side. 6g 1 minus cos theta. Divide this by 4a, 60 divided by 4a times 1 minus cos theta. Then you get cancelling by 2, 3g by 2a, 1 minus cos theta. This is your theta dot squared. 3g by 2a, 1 minus cos theta. That's the first answer we can very easily take. Right now? Okay. Yeah, next part asking hence or otherwise show that the acceleration of the particle p. Acceleration of the particle p. What is the velocity of the particle p? Velocity of the particle p is a theta dot. Acceleration means what, people? Acceleration means rate of change of velocity, no? Right? Then we can write here velocity of p. Velocity of p, right? What is that? A theta dot. A theta dot. B equals a theta dot. Acceleration is rate of change of velocity. Rate of change of velocity only, people, we can write by using the differentials dv by dt. Acceleration of p is equal to dv by dt. Then acceleration of p is equal to, what is v? A theta dot. D upon dt, a theta dot. A is a constant. Then we get d upon dt, theta dot. When we differentiate theta dot with respect to t, again, we get theta double dot. Then we get acceleration as a theta double dot. Now we'll keep this as star. Now we need to find theta double dot. To find this theta double dot, we can differentiate this both sides with respect to time t. Now we can write differentiating theta dot squared equals 3g by 2a times 1 minus cos theta with respect to time t. How differentiate this? First we have differentiate this 2, the power 2. 2 comes before 2 theta dot. And now we have differentiate this theta dot. When you differentiate theta dot with respect to time t, we get theta double dot. It is the angular acceleration is equal to 3g divided by 2a is a constant. We keep like the same. Now we differentiate this bracket. When you differentiate this 1, it's 0 because it's a constant. Now differentiate this cos theta, people, we get minus sine theta. Not only that, we differentiate this with respect to t, no? Then first we have differentiate cos, then minus sine theta. Now that should be multiplied by the derivative of this theta with respect to t. Derivative of theta with respect to t is theta dot, right? Theta dot. Function of a function derivative, theta dot. Then you can simplify here this theta dot. You can cancel down with this theta dot. Okay. Bring this 2 we are here, then we get theta double dot is equal to 3g divided by 4a. Here minus minus plus, we get sine theta. This is the answer of theta double dot. But the acceleration of p is given by what, people? A theta double dot. A theta double dot. Therefore, a theta double dot. Bring this a to this side. Then we get 3g divided by 4 sine theta. A theta double dot is the acceleration of p. Then you can write by star acceleration of p is 3g by 4 sine theta. 3g by 4 sine theta. Right. Now asking tension in the spring. Tension in the spring can easily be found, people. For this particle P, we apply F equals ma, right? For P, applying F equals ma, right word. Tension is T. If mass of the particle P is m, acceleration just now we found as here a theta double dot 3g by 4 sine theta. Then we get T as 3mg by 4 sine theta is the tension in the spring. Right. Find the reaction from the tube on the particle Q. This R also we have to find. To find this R, people, we can apply F equals ma towards the center for this particle Q. Right? We'll come to that now. Applying F equals ma. Applying F equals ma for Q towards center. If this is theta, therefore this is also theta, 3mg cos theta towards the center. 3mg cos theta minus r is equal to mass is 3m, centripetal acceleration. It is velocity perfect square divided by radius. Velocity at that moment is a theta dot. It's perfect square divided by radius a. Now you can subject r, take this right hand side and bring this side. This gives us r is equal to 3mg cos theta minus 3m upon a squared theta dot squared. This and this you can cancel down. R is equal to 3mg cos theta minus 3m a theta dot squared. Here, people, when I bring this a to this side, that will be a theta dot squared. It is equal to what? 3g divided by 2 times 1 minus cos theta. And then that a theta dot squared only there we need, that I write now a theta dot squared going to be 3g divided by 2a 1 minus cos theta. By simplifying, you get r. R can then be found, people. Here we can take 3mg divided by 3g divided by 2 only come in, no, people, not 2a. A theta dot squared, no. When you bring this a to this side, 3g divided by 2 only come in, no. Then I can take 3mg by 2 out. take 3 mg by 2 out. 3 mg by, we don't have 2 here, therefore we have to multiply this by 2. 2 cos theta. 3mg by 2 wants to take out. Here we have 3 minus 3. By minus 3 you have to remove the bracket. Minus 3 minus minus plus 3 cos theta. Okay. Then we get R. Three mg by 2, 2 cos theta, 3 cos theta, 5 cos theta minus 3. People, this is how we take the normal reaction acting on the particle Q. Right? Right now.